Okay? So you can use yours and then look at the ones that I've recorded from the other class, and they're going to be like these, where you have fractional exponents and everything, but they'll give you more examples to carry with you for next year. As Ms. Holloway from my class 2 years ago realized that if you don't learn things that I teach you, you have trouble in college. Just sent me a sheet with, how do I work this? And I wrote bow tie, but I don't like the bow tie. Then you can't work it. All right. First thing you do is you always take the derivative and find the critical numbers. F prime equals 1/3 x negative 2/3 plus 8/3 x to the 1/3. Now, you take the derivative. You set the derivative equal to 0. Now, here's where we're going to check. 1/3 x negative 2/3 plus 8/3 x 1/3 equals 0. I think everybody here knows I can factor out a 1/3. Is everybody okay with factor out a 1/3? Don't throw it away. I know it doesn't affect where it equals 0, but it's important. You're going to factor out an x. What power of x are you going to factor out? The lowest, yes, negative 2/3. Thank you for remembering that. Earlier this year, I kept stressing, factor out to the lowest power. The reason I kept saying that is because that's what you got to do now. Okay, that becomes 1 plus 8. And then if you factor out negative 2/3, 1/3 minus negative 2/3 is just an x. And that's what's so cool about doing it this way. Now, I don't like this problem because I can't believe that it's going to turn out to be negative 1/8 is what's going to make that equal 0, right? See how negative 1/8? For some reason, I just think that I may have written it down wrong because I can't believe he made up one that works out to be negative 1/8. And he did. Okay. Now, I'm going to check it. Yeah. Now, so, here's where we're going to look at our critical numbers. See the 0? Does that really make it equal 0 since there's a negative exponent there? What would that do? That wouldn't put the 0 here, it'd put the 0 where? In the denominator. Is that everybody okay with that?
Wait, I missed something.
Okay. See that x and negative 2/3? A lot of people think if you put a 0 there, you're going to get this whole thing to equal 0. You're not. If you put a 0 there, that 0 is not in the numerator, that 0 is actually in the denominator. Because you have a power of what? Negative 2/3. Okay, hang on. Don't worry.
Yeah.
Now, I still want to know where it equals 0, which is negative 1/8. Is everybody okay with the negative 1/8 part? But it also is important to realize that 0 is a critical number too. But above the 0, we'll put a little vertical line, and above the negative 1/8, I'm going to put a little horizontal line. They're both critical numbers, and we're going to talk about what the F graph looks like. But are you okay with the 0 is actually a critical number that makes the derivative what? Undefined. It's not differentiable at 0. Didn't say you couldn't take the derivative. I'm saying it's what? Not differentiable at 0. Now, do you know why I put the little horizontal mark and the little vertical mark? Someone tell me.
Yeah.
Okay, the negative 1/8 makes the derivative equal 0. So at negative 1/8, it's got to have a horizontal tangent. At 0, it makes the derivative undefined, which means the slope of the tangent line is undefined, which means it has to be what kind of tangent? Vertical. So I'm going ahead and telling myself that over here just to help me out. Is that okay? And you're looking back in your notes to see if you got there, right? From yesterday, do you? Take your time, look back, okay? Now, since this is f prime of x right here, what we're going to do is you have to pick numbers to test in your derivative. We're going to make our little chart. Pick a number smaller than negative 1/8. Negative 8. Is negative 8 smaller?
Yes, sir.
Let's take negative 8. Let's test negative 8. We're going to test negative 8 in our first derivative, f prime. Okay, if you put a negative 8 here, does everybody agree that's going to be a negative?
Yes.
That's going to be negative something, it's just going to be a negative. Now, when you put the negative 8 here, notice you're going to square it, right? That's going to instantly mean that any number you put in the denominator, any number you put in the denominator, when you square it, it's going to be positive because of that. Right there, you're going to square it, right? Okay? So when you put negative 8 in there, you get a negative over a positive, and a negative over a positive is a negative, so that thing is decreasing. It is decreasing all the way to negative 1/8. Anyone got a question there? Anyone worried about that? Anything you don't like about that? Somebody says, could you have tested it in here? Yes, but it'd been harder to test in there. It's easier to test it where you got it factored because then you can just tell where it's what? Positive or negative. Now, we need to test a number between negative 1/8 and 0. I am going to test negative 1/27. And the reason I'm picking that out is, notice how I'm going to have to take a cube root? See what I'm getting at? I want a number that I know how to do what? Take the cube root. Is it really going to matter that I pick negative 1/27? No, because what's going to happen when I square that anyway? It's going to be what? Square negative, still going to be what? Positive.
Wait, I don't know. Can you explain that rule? Like, I must have forgotten this.
What's that?
That exponent rule? Of the
If you raise a negative number to an even power, it's positive.
Okay. Yeah.
If you raise a negative number to an odd power, it's
You talking about like fractional exponents?
Yeah.
still the same.
Well,
See, that 2's
You
even,
have to
right?
Square it and then take the cube root.
Yeah, and when you square it, it's going to become what? Positive.
Yeah, I forgot about just the general fraction exponent rule.
Okay, that's the cube root, and that's the square.
Right, so what do? You cube it, or you
Cube
square
root it first.
You cube root it first.
But in my case, I don't even have to cube root it because I know when I cube root it, I'm going to get a negative. And then when I square that negative, it's going to be what?
Square it, positive.
Positive. And I'm not worried about the exact number. I'm just worried about whether it's what? Positive or negative.
Okay, so the rule is
Yeah.
you keep the bottom.
Keeps the number smaller if you do the root first. Now, but since that's already positive, I could have actually picked numbers that I couldn't take the cube root of and I'd been okay, right? I just didn't think about it that way when I was doing it. Now, but if I put a negative 1/27 here, I'm going to get 1 plus negative 8/27. And that's still going to be a positive, isn't it? So I have a positive here and a positive here. So if I have a positive over a positive, my result is positive. So that means between negative 1/8 and 0, my graph is going to be going what? Up. Increasing. Do you notice that you better be improving your algebra skills? Because what happens in college, the professor just looks at it and goes, between negative 1/8 and 0, that will be positive. And you need to test a number, all right? Somebody says, what would happen if you tested negative 1/16 or negative 1/21? Negative 1 over 64. Test any of those and this will be positive. Please just don't test a number that's smaller than negative 1/8, okay? It's got to be between what? Negative 1/8 and 0. All right. Then you're going to pick a number bigger than 0. We're going to test 1. Test 1. Positive over a positive. Thing still goes what? Up. Okay. That's based on our first derivative. I won't yell and scream in just a minute, but it's not at y'all, it's at everybody. Make your XY graph down here. Negative 1/8. Now, negative 1/8. Here's something you need to do. Let's go ahead and find the point values. Anytime you want a y value, you must look back to the original. Okay, does everybody know these two numbers right here are called critical numbers? Those came from your derivative. But when you want a y value, you must go back to the original. Turn to a blank page. For y values, go to the original. Write that at the top of a blank page. For y values, go to the original. Y equals equation. Yeah, to the original y equals. Then skip a line or two. For critical numbers, increasing and decreasing. Critical numbers and increasing and decreasing. Use the first derivative, y prime. Y prime tells you whether it's increasing, decreasing, or what are the critical numbers. Okay, skip a line or two. Concavity, inflection points. You use the what? Second derivative. And put out there smiling and frowning too for concavity so that you'll know what we're talking about. When does it smile, when does it frown? Okay, so I put negative 1/8 back in the original because I want a y value. Fair enough? I put negative 1/8 back in the original, and the cube root of negative 1/8 is negative 1/2 plus 2 times 1/2. Okay, if you take the cube root of negative 1/8, you get negative 1/2, but then you raise it to the fourth power, it's going to become 1 over 16. Now, some of y'all can't do algebra in your head. I'm not going to say that I'm saying that on camera. But you got to be able to do some algebra, folks. You put negative 1/8 in there, you take the cube root, it's negative 1/2. Raise it to the fourth power, 1/16. Positive. Now, you work that out. Get negative 1/2 plus 1/8. You get a common denominator. Negative 4/8 plus 1/8 is negative 3/8. So this point is negative 1/8, negative 3/8. And I feel pretty confident about that because I know it's going to go down to get to there, right? And then I know it's supposed to start going up until it gets to 0. And when it gets to x equals 0, what's the y value? 0. It goes through the origin. Now, just to help me out, when it goes here, we'll put me a little straight line like that. And when it goes here, we'll put me a little vertical line like that. I know that because that's where it equals 0, and that's where it was what? Undefined. I could probably guess a little bit about what this looks like. It's going to come down, down, down until it gets to right there. It's going to touch that. And then it's going to go up, up, up. And it's going to go through 0 and then keep going what? Up, up, up. And you can do a little soft light pencil graph of that if you want to. You already know this is a relative minimum. Is everybody okay? That's a relative minimum? Because it went down and it turned around and went what? Back up. All right, well, let's do our second derivative. I'm going to erase where I did the little test there. So if there's anything about the first derivative information you want to ask me, now's a good time to ask. I won't get angry. I won't throw a shoe at you because I'm on camera.
Wait, so where your 0 is, it gets like vertical
Yeah.
for a second?
Yeah, so what it's going to do is it's going to come over here, and it's going to go straight up, and then it's got to go out that way. So you can probably already guess the concavity if you start working enough of these. Yeah, see, and it's going to go, yeah, it's going to go straight up and keep going out that way. Yeah. You can get you a little rough sketch. But we're going to fine tune it. See, I was even kind to Mr. I taught his older brother too. Oh gosh. Okay. So much for that idea. Now on to the second derivative. On the second derivative, folks, go and take it from right here. Because do you really want to use the quotient rule? No, just take the second derivative from right here. F double prime of x equals negative 2/3 times 1/3 is negative 2/9. X subtract 1 is negative 5/3. Negative 5/3 plus 8/9 x to the negative 2/3. Okay, and there's your second derivative. You're going to set it equal to 0, and you're going to have to do what? Do some factoring. Factor out 2/9 or negative 2/9. I'm going to factor out negative 2/9, if that's okay with you. The reason I want to do that is that'll make that positive 1, but that'll make that negative 4. Okay? Then I'm going to factor out the x. What power of the x am I going to factor out? Negative 5 over 3. That all becomes a 1. Then x to the negative 2/3, it's just going to become x. Can't believe it. Does it really just become x? It does. It really does just become x, right? Can't believe it. Yeah, it does. So, does everybody agree that 0 is going to make this thing undefined? Which for your second derivative, that's not a big deal that it's undefined, because we need the important numbers, and they're where the second derivative is undefined or equals 0. This one is what? 1/4. Okay, so those are our important numbers from our second derivative. They're not called critical numbers. Now, to make life good, we're going to put one of them right here. And we're going to put the other 1/4 out here, which is actually further out than this, so 1/4. Now, if you want, you probably need to find out what the y value is for the 1/4. Wouldn't hurt. Or you can do the concavity first, whichever way you want to do. Let's do the concavity first. To do the concavity, we're going to pick a number smaller than negative 1/8. What's the easiest number in the world to pick? Negative 1. So we're going to test negative 1. Okay, does everybody agree that right there is negative? We'll put it right there. There's a negative. When you put negative 1 in here and you raise it to the 5th power and you cube root it, it's still going to be negative, right? Raise negative 1 to an odd power, it's still negative. I taught you that somewhere back there. You put negative 1 in here and you get a positive. So you find out for all the time that it is less than 0, it smiles. And somebody says, but can it go down smiling and can it go up smiling? Yeah, because I gave y'all little drawings of that yesterday, didn't I? So, it goes down smiling. It hits that point and it goes up smiling. Is everybody okay that it's smiling that whole way? Now, between 0 and 1/4, what number are we going to pick to test? 1/8. 1/8. We're going to test 1/8. Negative. Positive, because if you take a fifth and a cube root of a positive, you get a positive. Then you take 1/8 and you put it right in here. 1 minus 1/2 is a positive, right? So if you multiply that together, you get a negative, so it frowns. So it's going to come out of there, and it's going to come out of there frowning as it goes up. Somewhere out here, it's going to get to 1/4. Oh, Mr. Evans, it's got a frown. Okay, it's going to frown. And then at 1/4, maybe I don't need to write the 1/4 in there twice. How are you going to figure out what happens at 1/4? You're going to put a number in bigger than 1/4. What number are you going to test that's bigger than 1/4? 1. You test 1. Negative times positive times negative. You get a positive. It starts smiling. Smiles. I'm going to just erase that. And now it does not get flat, folks. It's going up, and it does not flatten out, and it keeps going up. Okay, but it does not go flat. It doesn't go straight across the board. See if I can make a prettier picture of it. It's going to go up, and right there it's going to change concavity at 1/4. And how are you going to find the y value? You're going to put that 1/4 back into the where? Back into the original. Where you always get the y values from the original. And that's going to be an inflection point. Actually, you've got 2 inflection points. You have an inflection point at 0, and you have an inflection point at what? X equals 1/4. And I guess I need to go ahead and find the value. Oh gosh, I don't want to find the y value because it's going to be the cube root of 1/4. Yeah, you better work that out for me, Evans. It's 1/4 raised to the 1/3 plus 2 times 1/4 raised to the 4/3. The scary part is, I'm just going to write 1/4 to the 1/3 or 2 to the 2/3. Does everybody agree that 4 is 2 squared? So I'm going to make that 2 to the 2/3. And the reason I'm going to do that is because then I'm going to make this 2 over 2 to the 8/3. Do you agree you can reduce that because that's 2 to the 1st? Right? And that's going to become 2 to the 5/3. So you can get 1/2 to the 2/3 plus 1/2 to the 5/3. And I'd probably just leave the y value like that, but then you could factor out 2 to the 2/3. 1/2 to the 2/3, and then that would become 1 plus something, and you get, yeah, it's a nasty number. Fair enough? Nasty number. But that's your y value. This is a hard one because this is not just nice, pretty, smooth curves like y'all saw in your AP class. In your AP class, everything was probably a really pretty smooth curve. You didn't have any vertical moments or anything like that. Okay, questions? I'm trying. I want you to do well when you get to college. I do not want you to look like the kids from some of these other schools. I do not want you laughed at in front of everyone. A class of 100 and you get laughed at, feel pretty bad. All right, well, I did a bunch with fractional exponents today. Let's do that one down there. Okay. Here we go. You're as bad as I get. You notice I'm working real promptly. I'm not working the chunk stuff at the beginning. Working the real. We're gonna work 57. 57. Who was it that knew that I was supposed to factor out to the lowest power? If you didn't remember that from earlier on this year, shame, shame. You know, I didn't watch the inauguration. I kind of wanted to. Don't you say anything. I'm just listening to me talk. Until you read Parliament of Whores by Mr. O'Rourke, you do not have any knowledge of politics, so that you can't talk. When you read Mr. O'Rourke's Parliament of Whores, then you're allowed to talk about politics with me. Until then, you just have to listen to me.
Whores or
Whores, like, yeah, whores.
Okay.
Ladies of the evening.
Ladies of the evening.
Yeah, Parliament of Whores. He writes a civics book. And he has chapters in it that are named like your civics book chapters. He said, this is what your civics book teaches you, and this is how it really works. You know, yeah, I know in civics you were taught this is how laws are made. But this is how it really works. It's a good book. Read it. Then you'll know enough to talk about politics. All right. Y equals parentheses x plus 1 to the 2/3 times x minus 2 to the 1/3. No, got 1/3.